Anyway. I guess I gotta do my thing. I gotta start going in the direction to do the thing. Okay, so we got some participants. We have some people in this meeting. As normal. As normal, we'll wait another few minutes, see if some more people show up. Because that's how it goes. That's how it goes. Yeah. Oh, okay, so riddle me this. Riddle me that. So you're my viewers. You are my meetup members. Okay, so why is this person... See, I have the Asheville meetup. The Asheville meetup. You know why it's called an Asheville meetup? Because we do it in Asheville. It's a place called Hatch Innovation Hub. We did our first class in a while there yesterday. And you come, and you bring your computer, and I teach you. Yesterday we did Introduction to Python, and I teach you, and we make sure your systems are up and running, and it's great. You know the greatest thing about it is it's in Asheville. So you're my viewers. I'm here to listen. I'm not here to talk. Why? Why are people from all around the world joining a meetup that specifically states that it's in person in Asheville? People are like, Eli, why do you get snarky? Why do you get mean? Why do you lose your mind? It's like, because I'm teaching free to the end user education that empowers people here in person in Asheville. And I get jackasses from Spain signing up. I don't think you're flying in. I could be wrong. Leo, what's your name? Dear Lino, if you are flying into Asheville from Spain, I highly apologize for this diatribe. But I don't think you're flying into Asheville from Spain. Anyways. This is stuff. This is the stuff you got to deal with in the real world. Like, everybody's worried about hackers. Everybody's worried about the Zimbabwean ninja hackers. How am I going to protect my business from the Zimbabwean ninja hackers? They're going to parachute in like Tom Cruise and destroy all my infrastructure. I am here to tell you your problem is not Zimbabwean ninja hackers parachuting into your facility to hack your systems. The people that are going to destroy you, the people that are going to shred your business, are the ones that say they support you. I love what you do so much, Eli. I love it so much, I'm going to burn it to the ground. Oh, what you've created is amazing. What happens if I throw a Molotov cocktail into it? Like, Anyways. That's the reality. Again, I have these sites. I now have Wix. I'm now using Wix. So we have Wix as our main site. And this is what we're using for Silicon Dojo. But in the past, I created sites. I literally created community sites for my community. And do you know who destroyed my community sites for my community? It wasn't anonymous. It wasn't Shaky Bear or whatever the hell the Russian's name is. It was my own viewers. My own viewers would hack my systems to show me the problem. I mean, like, I know there's a problem. It's an open system. I made a system that's open so that people can communicate better, and now you're using that openness to destroy the system. My viewer is destroying the system that was created to support my viewers. Anyways. Lino in the house! Come on, join Lino. Join for the conversation, Lino. Hey, Lino. Hey, Lino. Are you from Spain? Lino Ella. Are you from España? España? And anyways, you from Europe? Lino? From Zaragoza? We were just talking about you. And I was wondering why anybody who's in Spain would sign up for a class that is physically in Asheville, North Carolina? Lino, are you hopping a flight from Spain to come to Asheville, North Carolina to physically come to my class next week? If you are, I humbly apologize. I don't think you are. Don't sign up for classes you can't fucking attend. Anyways, why isn't Eli so happy anymore? It's this weird thing. If you look at Eli's videos back in 2010, he was so happy and energetic and full of life. And something happened between 2010 and today. Yes, something did. Anyways. In all seriousness, this is something to think about. Again, we do these classes, so we do these classes online. And we do these classes in Asheville, so we have the place to do this in Asheville. We are going to be doing these classes in Raleigh, North Carolina, and there might actually be a mobile edition. There were some conversations about the mobile edition. But here's the thing, wherever it's going to be, unless it's online. Online doesn't matter. I have 1,000 people sign up to this. Who cares if you don't show up? It's online. Here's the thing, in the physical world, there are only so many seats. You got a resource of seats. Again, we talk about denial of service attacks. And we talk about how denial of service attacks can be conducted by people who like what you're doing. They don't hate you. They're not Zimbabwean ninja hackers. And so the thing is, so when I do the physical classes, the resource that I have are seats, right? Ass gotta go in seats. It's like a port and socket or something. And so if you consume seats that you're not gonna put an ass in, you are literally doing a denial of service attack against what I'm trying to accomplish. You're doing a denial of service attack against somebody who is stupid enough to try to make the world slightly better. So anyways, if you sign up for crap you can show up to. It's not funny. It's not cute. It's not amusing. It just makes me lose my mind. Anyways, how y'all doing? Hi, I'm the one in Spain, and I came there. You can come here? You're going to be here next Tuesday. You're going to be ass in seat next Tuesday. I'm gonna put $5 on the table. That's incorrect. But anyways, if you come, cool. If you come, cool. If you come, I highly apologize. I will come out of the video next week and go, I highly apologize. But your ass better be in that seat. Hey, I'm going to, yes, anyways. There we go. 2:08. So enough of bitching and moaning. Enough of bitching and moaning. We gotta push this ball forward. Okay, so what's going on, everybody? So, we did do the first Asheville class, and it was adorable. I had one person show up. Yay! So anyways, you can try. Again, one of the things to think about with business, one of the things to think about with doing your project is, you gotta start somewhere. So we did our first introduction to Python class, in-person class, the first one we've done in a while here in Asheville. Yeah, so we did the class. She had her own computer. We got her working on Python and everything on her computer, got her doing labs. And so the nice thing is now her computer is now set up in order to do Python projects. So as we go forward, she will be able to continue to do stuff on her computer. So anyways, we did that class yesterday, and it went pretty well. Let's see here. Site. Just so you know, we do have our site nowadays. So we do have Silicon Dojo. So if you go to silicondojo.com, you will see our pretty site. The big thing here is this has all of our classes. So you can see the... I must have to refresh this. Anyways, as classes come up, whether they're on Zoom, whether they're in Asheville, whether they're in Raleigh, whether they're somewhere else, they will be here, and it's a place to see what is going on. It also has a membership directory. I don't know if you can actually pull it up since I'm not logged in. Anyways, just believe me when I say there's a membership directory, so you can become a member. Come on, Wix. Come on, Wix. Anyways, you can become a member, you can join the discussion on our forum, so on and so forth. Again, with all this stuff, it is free to the end user. It does cost me money to do all this stuff. There is a donor box link, and if you want to throw in $1, $5, preferably per month, that would be so lovely. But that is there. As far as social goes, if you go to GitHub and you go to online classes, all the notes and everything for all these classes are here. You can download them, you can use them. You can use them commercially if you want to. So it's GitHub, Silicon Dojo, online-classes. We'll get you to this particular folder. All of these classes, so I'm doing this on Zoom on this camera. There's a camera right beside it. That's a 4K camera. All these classes, a day or so after I do the classes, they will actually be uploaded to YouTube. So you can have the documentation from GitHub. You can actually watch this stuff in 4K on YouTube. And so if you miss the classes or whatever else, that is there for you. If you want to follow me on LinkedIn, I am Eli Etherton on LinkedIn. And I don't know, this is literally the only social media that I actually use. So that is there. Again, for Meetup, if you go to Meetup, we'll notice we'll have 3 meetups at this point in time. We have the online meetup that you are part of now. This is the online meetup. Oh, we have the Asheville meetup, and so the hope is to have 1 or 2 classes a week here in person, and then the idea going forward is the Raleigh, the Research Triangle meetup, where probably doing like more like boot campy type things every month, month and a half, whatever. I have to figure it out. It's 4 hours away from me. Basically go there, spend the time, and then do like a boot camp on Python and a boot camp on Bottle and AI and that kind of stuff. So that is there if you want to become members of that. It's okay. You can become a member. Feel free to become a member. Just don't RSVP to things you can't show up to. That would be ever so lovely. Yeah, and I guess the final thing is if you are in the Asheville area, there is Meet the Geeks tonight. Meetup, they're a great little tech meetup here. They've been around for about 15 years. So they're doing Meet the Geeks tonight. I will be at Meet the Geeks. If you're in Asheville and you'll come to Meet the Geeks, I don't know, it's good. It's beer, it's pizza, it's geeks. I don't know what else anybody wants. And then the final thing, of course, if you have a question, you can always raise your hand during class. Basically raise your hand in Zoom, wherever that is, because if you do this, I'm just not going to see it. So use Zoom. I do answer questions when I get to them. And that's all I got. So, okay. Bop, 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 bop. Any questions? Any questions before we get into class? No? I got blocked by Eli on LinkedIn. Ooh. What did he do on LinkedIn? Oh, are you being a jackass on LinkedIn? I feel so bad for you. Yeah, if you act like a jackass, I block you. That's generally how it works. You want sympathy? You want sympathy? Go find Lewis. Go find Lewis. Lewis Rossman will give you all the sympathy you want. Remember, he's the nice one. He's the nice one, not me. Not me. I'm not the nice guy. Anyway, will there be a class in Raleigh? Yeah, well, soonish, sometime. Yeah, I love Raleigh. To be clear, as snarky as I get. You know me. I'm a snarky bastard. Let me tell you, but I'm honest. Raleigh, Research Triangle, they're so nice. Like, so nice. It's like adorable. It's like weird. It's like Pleasantville in the tech world. I've never seen anything like it. I've seen San Francisco and Austin and Seattle, DC and New York. I've seen all kinds of tech scenes. Like Raleigh, Research Triangle, it's like, oh. You want to get like a malt float or something. I don't know, it's like Pleasantville of the tech world. And they actually have tech. They've got Microsoft, they got Google, and Apple's putting in $1 billion facility and the whole 9 yards. So they're the loveliest people. Truly. I mean, I was like, what? I'm like, Raleigh, what do I do with these people? You ever have that where you start getting PTSD because people are too nice? You're like, hello, how are you? What does that mean? Stay back. No, actually, lovely people. So I love Raleigh. I love the Raleigh area. So anyways, yeah, we are going to be doing classes there. Again, I have to get space, and there's a whole bunch of rigmarole, a whole bunch of processes that have to occur. So we'll get to that someplace. Kansas City is the place to be. Sure. Whatever you have to say. Okay, so we are going to talk about web app architecture today. So a lot of stuff that I'm going to be talking about today. If you've been following along with the other classes, we are going to say a lot of the same words that we have said before. We are just going to kind of reconfigure some of those words to talk about web application architecture. And that's one of the big things to be thinking about whenever you think about the technology world, is we have pretty simple Lego blocks. Again, Don't tell any of the old timers that I said this, but technology is pretty simple. Let me be crystal clear. Most of this horse crap is really simple. Again, you don't have to be smart, you do have to be precise. Where it gets complicated is when you start building the stack. You got simple, 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 simple. And again, when does something go from being simple to being complex, right? TCP/IP or Ethernet, pretty simple. TCP/IP, pretty simple. OS, pretty simple. Python, pretty simple. Bottle, pretty simple. Nginx, pretty simple. At a certain point, it gets complicated. Anyways, that's one of the things to be thinking about whenever you're going to be building things with technology and we start thinking about the stack, is we take all of these relatively simple concepts and we plug them together like Lego blocks in order to create our finished product. And our finished product is going to be whatever the hell solves our problems. That's all we do. What do technology professionals do? We solve problems with technology. So one of the first things you have to be thinking about, again, if you're going to build web applications or anything else, is what problem are you actually solving for? When we talk about what problem you're solving for, that means what does the client or your boss, what do they actually need? What are the resources that are available? What is the institutional knowledge? Just because you can build something doesn't mean the rest of the company can support the damn thing, right? There's a whole bunch of this stuff that comes together in order to figure out whatever product it is that you're trying to ship. Now, I really push web apps. I love web apps. One of the reasons I love web apps is because you can build a web app and it runs on anything. It runs on anything, right? It runs on your desktop computer, it runs on an iOS device, it runs on an Android device, it runs on a phone, it runs on a tablet. You build a web app and it will run anywhere. And this is something that's very important to be thinking about, especially if you work for a startup company or you're trying to spin a startup company, is do remember, money is a very finite resource. It's a very finite resource that you burn through very quickly. So one of the big problems that you see with a lot of founders is they burn through their cash. They burn through their runway, and then their pathetic little startup company hits the trees at about 500 miles an hour, and everybody goes, ah, right? And one of the reasons is because they waste a lot of money while they're trying to validate their idea. Again, when we talk about Silicon Dojo, one of the things I'm trying to do is validate the idea, right? People like the idea. They pat me on the back and they give me a cookie. But again, when you have one person show up to your class, that's a bit of a question mark, right? Again, like this is my idea, what I'm doing right now. So we've got however many people we have in this particular meeting. So this shows me the traction that I have online. I did this in person in Asheville. This shows me the traction that I have in Asheville. And we'll try to do things in Raleigh and we'll see what the hell the traction in Raleigh is. And what I'm trying to do here is I'm trying to validate this idea that I have, right? Authorities, gatekeepers, free games, use your hands-on technology education that empowers you to do whatever the hell it is that you want to do. There's the idea. But then how do we deliver it? How do we deliver it in a cost-effective way that actually has some kind of return on investment? So again, here, online, seems to be working well. Asheville, I don't know. Again, whatever my version of success may be defined as, or in Raleigh, we'll go and we'll do it in Raleigh. So that's one of the big things to be thinking about, is validating your idea. So if you are a founder, or if you're working for a founder, and the founder wants to validate their idea by creating a not native iOS app, and creating a native Android app, and creating something else, each one of those apps is going to require time, energy, money, resources. And you are burning through your resources before you've even validated whether or not anybody gives a damn that your product exists. So the cool part about doing a web app, as again, especially with the HTML5 APIs that I showed you folks a week or two ago, is that you can do a very powerful app that runs on absolutely anything. You code once, essentially deploy anywhere. If you need to update it, You just go to literally to your web server code and update it, and then you can start getting feedback from your users to determine what they do or do not like. This isn't here, this functionality doesn't exist, blah, 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 blah. And then as you go through, you can validate your concept and then narrow down into what you actually want to accomplish. Again, when you do a web app, you do not have to get approval from Google, you do not have to get approval from Apple, you don't have to jump through those hoops, you do not have to pay developer fees or any of that kind of stuff. So that's why it's important to be thinking about, with web applications. And I really think most startups should go for the web applications. We start talking about web applications, one of the big things to be thinking about is the difference between speed and latency. This can catch people off guard, especially in the modern world where everybody says that they have high-speed internet. Eli, don't worry, my web app will work fine. Everybody has high-speed internet. Okay, yeah, but what's the latency? Right? You know, for the app, for whatever it is that you're creating, you may not actually need high speed. 2 megabit per second with 20 millisecond latency might actually be superior for you than a very high speed with piss poor latency. So basically what we're talking about with speed and latency is basically, think of speed as how long it takes the entire thing, the entire object, essentially, from going from point A to point B, right? So server is here or whatever, client is here, and you're gonna send 1 gig of file from point A to point B, right? Again, back when I was in the military, back in the 90s, there was something called burst transmission. That was a big deal. A lot of the communication systems didn't have a constant communication stream. Basically what they did is they balled data up in this one massive package or whatever and just sent that thing halfway around the world, right? So that is very fast. That is very fast. And this could, you could send a 1 gig file in, 1 second, and then you have 1 gig per second, right? Theoretically, depending on how the math all works. So this is fun. So if you're sending OS updates, or if you're sending like updates, if you're sending images, maybe if you're sending video files, like anything that is going to be like a file, like I am sending you the digital object, right? Speed is generally fine. The issue you get into with latency is things like real-time communication. So we talk about real-time communication. This is voice over IP, talking on the phone. This is WebRTC, or like basically video, voice over IP. This is playing video games. And basically what we talk about with latency is it's not necessarily how much, but essentially how fast can the data go from point A to point B. And that's where we talk about things like 20 millisecond latency, right? That's literally, it may not be a lot, but that little is going really, really, really fast. And so again, that's where you talk about with speeds. That's where you hear about 1 gig per second, 100 megabits per second, something like that. But then one of the more important things is to be thinking about what is the latency, and frankly, what the hell latency does your app need? Again, if you're just sending files, who the hell cares about the latency? Even if you're doing like YouTube videos, who cares about the latency? In some ways, even a Zoom call. Again, and that's where you have to be thinking about like what's actually occurring, right? If I'm just doing, let's say, a webinar, if I'm just doing a webinar where I'm talking to the camera, and then let's say the only response that I'm getting is in the chat stream. So we're not doing talkie, we're doing talk chat, right? In that instance, latency might not be that important because I talk and then I have to read your thing, and so there's no jitter, there's no weird crap, and so I answer, so latency might not be as big a deal there. Whereas again, if we're talking, if I say a word, and then you say a word, and I say a word, you say a word, and I say a word, we need that latency to be really, 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 really quick. Theoretically, you'll hear numbers that I think sound stupid. Theoretically, for voice over IP, you can get up to like 100 milliseconds of latency. That is what I've been informed by the vendors. I'm not sure I trust that. I would say with like voice over IP, you probably want something like 50 milliseconds of latency. But these are things to play around with your particular app. The other thing to be thinking about when we start talking about latency is you need to think about latency for the entire Oh, for the entire trip, basically the communication trip. So I saw a voice over IP company fail because everything had to go through Amazon servers. So they decided to create an enterprise class VoIP company, basically VoIP as a service company in 2012. Going through AWS's system, right? So one of the things you have to be thinking about, and we talk about this latency, is you're like, well, Eli, I do my pings and I get 20 milliseconds in latency, right? So we got great latency on our server. But one of the things you have to be thinking about is how is that working out? So if you're here and they're here and you have, let's say, 20 milliseconds of latency between you two, that's fine. That's going to be about as good as you could ever want. Here's the problem. What if you spin up your server on AWS and for some reason the communication now has to go through AWS? Now again, to AWS, if you have 50 millisecond latency to AWS, they have 50 millisecond latency to AWS. You now have at least 100 milliseconds of latency, plus you have the time it takes for AWS to figure out what the hell to do with this traffic coming through it. That might add its own 50 milliseconds of latency. So basically you go from something like 50 milliseconds of latency that would actually be fine enough for voice over IP, and all of a sudden you're looking at something like 150 milliseconds of latency that a voice over IP application would be absolute dog crap. And so this is the kind of thing that you have to be considering when you build your web applications is, again, what does it look like? I know, you come to these classes and I'm like, architecture. There's a reason I talk about it, because literally, like, what are you trying to solve for? So, like, one of the reasons for this, one of the reasons VoIP can get screwed up is firewalls. So basically, what's supposed to happen, like if you have VoIP communication, is so you have the client here and you're here. So client, me, and you got firewalls between the two of you. So the idea is the VoIP connection server is supposed to be up here. So the idea is the client communicates with the VoIP connection server. You communicate with the VoIP connection server. You do this handshake. And then what's supposed to happen is the communication is supposed to go between the two of you. Again, we start thinking about what is the process for this communication. So this basically is used as a list for everybody who's online. This is used as a way to do the handshake to get these people to actually be able to communicate with each other. And then the idea is it's supposed to hand off for peer-to-peer communication. So again, if all this is a listing cataloging service, who really cares about the latency? Listing cataloging services don't need a big latency. If you need to do a little handshake here, again, you want the latency to be low. It doesn't really matter. If it takes 1 second to do a handshake or 2 seconds to do a handshake, are you really going to lose customers over that? Probably not, so that's pretty good. But the idea then is it's supposed to do the handshake and then they're supposed to communicate between each other and then again, hopefully be somewhere around that 50 millisecond latency. The issue is with firewalls. Again, we talk about security. And we talk about cybersecurity noobs who really lock down their systems. Have you ever seen a cybersecurity professional lock down systems to the degree that the business can no longer function? I have. Again, have we talked about who's most damaging to the company? So anyways, here's the thing. If the firewalls are really locked down, sometimes this peer-to-peer communication will not be able to occur. And so basically there's a system in place to then force the communication to go through this server. So again, that's where I say instead of having that 50 millisecond, all of a sudden you have 50 milliseconds here, you have 50 milliseconds here, you have 50 milliseconds here, you got 150 milliseconds, and it's just garbage. It's not going to work worth a damn. And so again, these are the kinds of things that you have to be thinking about. That's where we talk about firewalls and communication, all of that kind of stuff. And again, things like latency. So again, especially in 2012. So 2012 is a long time ago. To be clear, 2012 was 12, 13 years ago. But the latency was garbage back then. VPS servers, the latency to VPS servers was absolute trash. And so again, we talk about from an architecture standpoint, even if you were going to do this, if you had your own hardware, so if you had your own server, a bare metal server, you had a 1 gig pipe going into a bare metal server in a co-location facility, you may be able to drop the latency, right? So if it's not going through AWS's cloud, maybe you can get the, I don't know, latency down to, let's say, 20 milliseconds between the parties because it's a clearer connection. And then since you've got a bare metal server, maybe you can make the process communication better, so that adds 10 milliseconds. And so maybe doing it this way, doing a bare metal system instead of an AWS system, you might be able to still keep your latency below about that 50 millisecond mark. And these are the kinds of things to be thinking about. Again, we start thinking about, speeds and latency and how all this kind of stuff is going to work. Let's see here. DNS. So DNS is a big one. So domain name service. So this is what is going to resolve your IP address or your domain name. So CNN.com, EliTheComputerGuy.com, SiliconDojo.com to the IP address. Now, do you remember when you're creating these web apps? Again, IP addresses. This is what computers actually care about. TCP/IP4 addresses are what computers actually care about. But again, your users are never going to remember IP addresses, and that's why we have these fancy domain names, CNN.com, blase, blase, blase. I will tell you, if you're going to go out there and you're going to become a founder of this billion-dollar company, get a .com domain name. Nothing else but .com. .com, and you're good. Again, I've been in this business. I had a .info. I had a .info back in the days when you would plug a .info email address into a JavaScript validation form, and it would fail you out because it wasn't considered a real domain name because it had 4 characters in the suffix instead of 3. But again, you're going to go out there, and there are a lot of dots, right? The parent directories or whatever, .coms, .edus, and .bizes, .orgs, .ios, .ai. Great, but .com. Here's one of the things you're going to find about human beings. We're kind of dumb. We're kind of dumb. Here's the thing. Your life will be much easier as a technology professional if you just accept humans are kind of dumb and move the hell on. No argument. We're just kind of stupid, right? People are used to plugging .com in. Whatever your name is, they're used to plugging in .com, right? .com, .com. It's just how it is. You do .io, you do .ai. Yeah, you feel really cool when you go to those tech meetups. Here's the thing. Your customers ain't going to plug that crap in. They're going to plug in .com. So just get a .com domain name. Anyways, when we start taking a look at these domain names, basically we have records. So let's go take a look at my DNS record for something. So I use Cloudflare. And again, I know you all think I'm just snarky and I hate everything. That's not correct. I hate stupid things. I like Cloudflare. Raleigh and Cloudflare. I like these. Cloudflare for DNS, actually, you really should think about Cloudflare for DNS. They are a pretty good solution. They're relatively inexpensive. They give you SSL, if you know what the hell SSL is built in. They do Proxy and a whole bunch of other stuff. I would tell anybody in 2024, use Cloudflare for your DNS. Anyways, you're going to see some records here. Hopefully you can see these. You are on Zoom, so your resolution might be crap. The 4K camera can see this fine. Whether or not Zoom, who the hell knows? Oh, what are you doing? Don't verify. I don't want you to verify. Anyways, so this is what your DNS records look like. So you're going to go to a DNS registrar. Don't go to GoDaddy. GoDaddy used to be good. Now they want like $20 a year for a domain name. Anyways, go to a registrar, cheap DNS, Cloudflare, somewhere. And basically that's where you're going to buy a domain name. You're renting a domain name. You pay your $10 or $20 or $100 a month or $100 a year for the domain name, and then with that, they will give you a panel so that you can modify your DNS settings. The first setting to take a look at is what is called your A record. Right? Basically what your A record is this will go to root, so SiliconDojo. So this is for SiliconDojo.com. It'll go to root. Normally you put an @ symbol for your A record. This automatically plugged in my domain name. And then you plug in the IP address. So 185.230.63.107. So this is the IP address for the server. This is actually for Wix. This is a little bit weird, but anyways, is what I got to show you, right? And so basically what this will do is if you go to silicondojo.com, not www.silicondojo.com, but if you just go to silicondojo.com, you ping silicondojo.com, this is what you will get if you ping it. So 107. So if I go and I ping it, ping silicondojo.com. There we go. So we get 185.230.63.107. And I hit Command C, Control C to stop it. Just out of curiosity, this is a bit different. Oh. 1 second. Ping. Okay, there we go. Now you'll notice when I ping www.silicondojo.com, I get an entirely different IP address. Normally this isn't how it should be, but I'm using Wix, and so anyways, you get reality here. So basically, silicondojo.com, just silicondojo.com, no dots before, no prefixes, none of that horse crap, silicondojo.com, that points to this particular IP address. Then you have your CNAME. Your CNAME. And what we're talking about when we're talking about CNAME is whatever the hell goes before the domain name. www.silicondojo.com, mail.silicondojo.com, remote.silicondojo.com, blah, 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 blah. Anyways, basically with this, so your A record, you're always going to be pointing to an IP address because that's what computers actually care about. With the CNAME record, you're going to be pointing to a DNS name. Normally, you're pointing to silicondojo.com. So if this was normal, I wasn't using Wix, it would say CNAME, www.silicondojo.com. So if somebody goes to www.silicondojo.com, it would point here, that then points there, and then it would send me to the web server. And that's how it would work. Wix is doing what Wix does. Now to understand, again, you're looking at this IP address, you might be like, huh. Okay, but how does the server, right? So you got a server, you got your VPS server, you got whatever else, you got your server. Right, so the server is 185.blah.blah.blah, whatever. Right, and so let's say this is a Apache web server. Now you may have heard that you can run multiple websites on the exact same server. So how does that work? That works because when the user goes to your website, that information is in the header for when it ends up communicating with the server. Right? So if you go to silicondojo.com, it'll point you to this IP address. That's an Apache server. In the Apache server is something called a vhosts file, a virtual hosts file, which is its own thing. Again, we talk about virtual, there's a lot of virtual stuff out there. It's not virtualization. It's not a VPS, it's not an instance, none of that crap. It's just called a vhost file. And basically what happens with the vhost file is they have a default, right? So the default basically will send all users into a specific directory. And then they'll have, Silicon Dojo will send into the Silicon Dojo directory. And Eli the computer guy will send into the Eli the computer guy directory. And CNN will send in the CNN directory, right? So you have these folders. And then based off of what website the user is trying to access at this IP address, they will get directed to the index, generally it's called index, or home, or default, blah, into there, and that is what will get returned. So that's basically how the resolution works for websites, right? So you get the A record for the domain name to the IP address, the C name for the www mail blah blah blah, and that points to an A record that's already been created, and then vhost file on the server figures out what the hell else is going on. You then have these other records down here. So you'll notice MX records. So these are going to be important ones for you. These are called the mail exchange records. So this is how email gets routed. So if somebody plugs in, Eli at blah, Silicon Dojo. I actually don't know why this is there. I don't have email. But anyways, so basically this is how it routes. So, I think its priority is low to high. Is it low to high or high to low? I don't know, it's been a while since I've played around with my MX records. You kind of set your MX records and then forget about them. Anyways, so whatever email service that you're going to be using, they're going to give you a set of domain names that you should point your MX records to. Basically, why you have multiple here, so why we have 5, is so these are failover. If somebody tries to send an email to this domain, so basically try to send an email to you, eli@silicondojo.com. It'll initially, let's say, go to this domain name. If for some reason the server is offline, network traffic, server blew a fuse, God knows what, it will automatically route to the next one, automatically route to the next one, automatically route to the next one, automatically route to the next one. And if that doesn't work, then it'll bounce back to users. So that's why you have these MX records here. And depending upon the email service provider that you use, you may have anywhere between like 3 to 10 MX records that you can plug in here, and that's what the mail exchange records are for. You will then also see name servers. These are fun in the modern world. Cloudflare, just so you know, if you use Cloudflare, you cannot change your name server records. It's about the only downside to Cloudflare. Basically what the name server records are, is these are the actual servers that do that name resolution up here. So many times, if you start using somebody's services, again, to host your website or whatever else, within DNS, they're going to want you to change your name server records to whatever the hell their name servers are to make life easier. So like with Wix, right? Wix would really prefer the name server here was Wix's domain names. So when somebody tries to resolve Silicon Dojo, they'll automatically get routed to the name servers of Wix, and then Wix's name servers will be able to do the resolution, and all that kind of stuff will happen. With Cloudflare, they don't allow you to do that, so then you got to get some ugly mess there. So anyways, that's that. Then we have GeoDNS and Anycast DNS, and this is something interesting to be thinking about in the modern world, again, especially if you're worried about latency. I would argue, in 2024, do you still have to worry that much about latency? Again, I think one of the big things to be thinking about, we talk about legacy, right? Legacy technologies will not die when they're supposed to. Kind of like legacy practitioners. It's a funny thing. When people have been doing technology for decades, it's kind of funny how they keep trying to build technology the way they would have done it in 2005. And again, with latency issues, and we talk about speed, you know, how long it takes to get from point A to point B geographically, right? Latency used to be a big deal, right? So if you have, the United States, you have the United States here. All right, so back in the day, if somebody was here and somebody was here, right, if the server they were trying to interact with was all the way across the country, right, the latency there might be high because the packets, right, the communication actually has to go all the way across the country and then back again, right? If you're on this side of the country and the server's over in New York, they go all the way across the country and back again. Then again, you go back to 2004, 2005, ooh, oh my God, the latency. And so there's this idea, right? There's this idea, well, why don't we put a server near them, and 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 a server near them? So the idea, right? So if this person is trying to get to your service, they just literally get routed to the closest server. If they're trying, they get routed to the closest server, and so on and so forth. The idea was to physically spread your network around the country or the world so that the servers were physically as close as possible to your end users to minimize latency. In 2005, gotta say something, it's gotta be shocking, it's 2024. Network infrastructure is slightly better than it used to be. So one of the questions that I would give you, if you're thinking about doing this mess, because it is a mess to design, is do you really want to do this? Or do you really just want to set your servers up in St. Louis and be done with it? Everybody's close enough. Again, if you're watching a YouTube video, do you care about latency that much? If you're downloading files, do you care about latency that much? If you're doing 99.9999999% of the things that you're going to be doing with your systems, do you care about latency that much? Again, if you're doing video games, right? If you're coming out with the next Call of Duty, by all means, spread your servers all over the country or all over the world. If you're doing the next YouTube, do you really care about that latency? Anyways, so if you do care about the latency, that is where Anycast or GeoDNS comes in. And so basically what this is it's pretty cool. So different DNS services provide this. So this is a service. This is completely normal nowadays. The only question is how much you're going to pay for it. If you try to get GeoDNS or called Anycast DNS with Cloudflare, you're going to pay through the nose. You're going to pay so much money. If you try to get it with some other provider, you might not pay that much money. But the idea, right? So you got this country. And again, let's say latency matters. You're a real geek. You're a real geek and you want the lowest latency. All right, so you got your server here, and you got your server here, and you got your server here, and you got your server here. There's a question, again, from a practical standpoint. Again, every system has to get built. So if you have a user that's here, how are they going to be directed to the server? From a practical standpoint, are you going to have them manually plug in? Are you going to manually say, which server do you want to connect to? That's kind of janky. So basically the idea with Anycast DNS or GeoDNS is they go to resolve your domain name, right? They go to resolve CNN.com. And then basically, when they resolve that to the DNS server is essentially going to do a query more or less against your IP address. And so we showed you this before, where there's databases with IP address geographic information that says, where is this IP address located? And so what it'll do is it'll see where you're located, and then based off of where you're located, it then will return the IP address that is theoretically closest to or most appropriate to you, right? So this might be 205.66.44.3, and this is 200.44.55.1, and this is 160.88.94.20, and this is whatever, right? And so basically it's going to see what is your geographic location, and based upon its rules, it's going to go, oh, this is the IP address that you're going to resolve to. You are then going to use that IP address to go to that server. Again, that server then has the vhost file, and then it'll dump you into the website or the web application that you're trying to go for. And so this is what GeoDNS looks like. And again, it's one of those products. Absolutely amazing. Also not as valuable as it was, 10 or 15 years ago. Okay, let's see here. Then we get the services and protocols. So this is going to be a big thing to be thinking about with your particular web app. Like when you start building your web app, what are you actually building? Again, if you're building a website, you're fine. Don't worry about services and protocols. If you're doing something more complicated, again, voice over IP communication, maybe you're communicating with surveillance cameras, IoT devices, that type of thing. One of the things you're going to have to be thinking about is basically what protocols are being used. Again, TCP protocols. TCP IP version 4 is the networking protocol that we use. TCP is Transmission Control Protocol. And basically what Transmission Control Protocol does is it's the communication for the services, right? So the IP address protocol is where you do, let's say 192.168.5.1, right? That's the IP. That's the IP part of the protocol. But then there's colon, and there's colon. And after that, there's generally colon 80, which is TCP, which is TCP, which is HTTP. So basically what this is the default port. Port 80 is the default port for HTTP. HTTP is what you use in order to look at websites, right? The thing is, when you're dealing with computers, there's a whole bunch of other ports out there. There's port 22, which is SSH. I don't know, fuck. I forget these. It's been a while since I've taken a test. That's what Google's for. Anyways, there's port 25, which is FTP, port 443, which is SSL. I was like, if you go to college, I'm just going to tell you, you're going to college, you're going to learn like 20 of these, and then you're going to pass your test, and then you're going to use Google. But anyways. Right, so there's lots of different protocols out there. So like when you're doing voice over IP traffic, there's a protocol called If you're doing like YouTube traffic, YouTube-ish traffic, there's a protocol called RTMP, Real-Time Media Protocol, and that uses a port. I forget what port. Again, if you're doing voice over IP, depending on how you do the voice over IP, there's a protocol called SIP, Session Initiated Protocol, and I don't know, I use a port too. It's on Google. It's on Google. It's why we got Google. And so one of the things to be thinking about is when you set up your web app and you have it communicating with different services, you do have to figure out what protocols are going to be used to make sure that your firewalls are open to allow that kind of protocol communication, and just to be sure if you're sending information to your clients that they can actually get that information. Nowadays, the whole protocol and the port thing isn't as bad as it used to be. This used to be a damn disaster. Let me tell you, back in the day, we used to sell surveillance camera, DVRs, digital video surveillance camera systems, and they would all come with their little mobile web app thing. And this whole port disaster, oh, there is nothing, well, there's a lot of stuff worse. Anyways, it is really horrible when you have a web application where they do not document the ports that are being used, and you have to push a hole through the firewall so that the ports work properly. Things to think about. David, what's up, David?
Hey, so you said it's a it's the IP/TCP protocol. Is like SIP and VoIP part of that, or is IP TCP one thing and the others are a different thing?
So there's TCP IP version 4, right? So these are the address. Whenever we talk about like 192.168.1.5, this is the networking protocol that is used. So TCP it's a protocol suite. So TCP is transmission control protocol. And that basically, more or less, manages the actual communication between two computers. IP, the internet protocol, is what allows the users to actually find each other on the internet. So basically, you use an IP address to find the other user, and then once you've found the other user, TCP takes over for the communication to go back and forth. So TCP/IP version 4 is considered a protocol stack, so there's a lot of protocols that are then built, or it's a suite, it's a protocol suite, there's a lot of protocols built on that suite, and so that's where we talk about HTTP, and then as far as I know, I think RTMP and SIP are basically protocols that are then built on top of this stack. So they're using IP and they're using TCP, and then they add additional functionality together to make whatever service function.
Gotcha, thanks.
That makes sense? Okay. Yeah.
Yep.
It's all... yeah. It's kind of like sometimes with like technology, it's kind of like with that whole... it's like magic thing. I've been watching this show called The Magicians on Sci-Fi or whatever, and it's like they sit there and they don't understand how to do something, and then one day they like squint really hard, and I don't know, a building blows up. They're like, I know magic now. It's kind of how it works with technology. It's like... I don't know, like at some point this goes from making no sense to making perfect sense, and you don't understand why anybody else would not grasp what's going on. So yeah, but yeah, so TCP/IP is the protocol suite. All this other stuff is built on top of it, and so again, that's why things like TCP and IP still matter. So there are other protocols out there, which are basically just pure protocols. All they are is a pure protocol. It's not a suite. It does specifically what the hell it's supposed to do. Pelco, God help you if you have to use a Pelco protocols. Anyways, that's that. And yeah, if you have any questions, just raise your hand and I will get to you as soon as I have a moment to pause. Okay, so then we get to SSL. 25 is SMTP. Oh, well, there you go. 25 is SMTP. I don't know. 21 is FTP. I don't know. It's what Google's for. Okay, so then we get to SSL and HTTPS, and this has become more and more and more important because everybody is worried about their privacy. when you go to CNN.com, you do not want the NSA spying on you. And I'll tell you, don't worry, they're not going to spy on you through this. There's more interesting ways to spy on you. Anyways, so again, as we talk about with TCP/IP version 4, when we talk about HTTP, when we talk about this mess that we currently call the internet, one of the biggest problems with it is we're using it for crap it wasn't designed for initially. We should be long past IPv6 at this point. Again, when I learned about TCP/IP4, when I took my TCP/IP4 version 4 test in 2000 or whatever, I was literally told by my instructor, he apologized that we had to take this test because IPv6 was only 2 years away. Only 2 years away. A far superior protocol. We will be using IPv version 6 within the next couple of years, but we're currently on IPv4, so you gotta learn it. Right? We're still not on IPv6. We should be on IPv10, like literally at this point. But anyways, the problem with IP version 4 is that it was not built for anonymity. It was not built for security. It was not built for all of these things that people demand at this point in time. When, basically when you had ARPANET back in the day, that got turned into the internet and all that type of thing. Basically, originally, it was for military bases and that type of thing to be able to communicate with each other. Basically, you had known good facilities using known good equipment to talk to other known good facilities using known good equipment. Right? You get the mess of what happened with the internet because after the military built out all this infrastructure, literally the next people they gave it to were the colleges and universities. So imagine the universities in like the mid to late 70s and early 80s. And the people that went to universities at that time period. And imagine the military people. That did not go together very well. But anyways, the big problem there was it was all governmental institutions, those types of things. So it was known good all of the way around. And so they didn't worry that much about security. Again, physical security. You don't have to worry as much about encryption of things if you have good physical security and the rest of it. Well, then we get to this internet, and everybody starts using the internet. And that's a different world. It's a different world. So people care about security and anonymity, and they want to believe they have it. Anyways, so that's why we get SSL, what's called HTTPS now. So again, if you go back 10 years ago, most websites did not have SSL on them. If you logged into a website, it might have SSL. If you ran a credit card payment, it might have SSL. If you did anything that was personally identifiable, it would run SSL, but otherwise you just went to plain vanilla websites that literally had no encryption. So basically what we mean with no encryption is it was no encryption in transit. Right? So if the site is up on the internet and you're at your house and you communicate up with a site, this was not in any way, shape, or form encrypted. So if somebody can get into the middle of this by hook or by crook, they can read everything that's going back and forth with absolutely no problem. And so what SSL does, it's called Secure Socket Layer, and what this does is it does encryption in transit. So all of a sudden, you make your communication between your user or your computer and the server. It is now encrypted. So if somebody tries to see what's going on, they're supposed to get an encrypted mess. Basically, they're not supposed to be able to read it. Again, encryption in transit. This has become a big thing, what was it, 8 years ago? So Google started deprioritizing sites that weren't running SSL. Like anything. If you have a Magic the Gathering card game website, all of a sudden, if you didn't have SSL on the damn thing, you were getting deprioritized because Google decided encryption was like the most important thing in the world. So anyways, whenever you're dealing with sites, it is something to be thinking about with SSL. So if it's just you and your users and you know exactly what's going on, you might not need SSL. But SSL comes up for Google. It'll be deprioritized in 2024 if you don't use SSL. Also, For phone apps, we talk about HTML5 APIs. So HTML5 APIs, we had a class on it earlier. Basically, it allows you to use JavaScript in order to communicate with hardware functionality on your phone or device. Many times, they actually require SSL, encrypted communication, for some reason. Why? I don't know, but they do require it. So if you're going to be creating these kinds of apps, SSL is something to basically look at. If you go to GoDaddy or a lot of providers for VPSs or whatever else, you can buy what's called a certificate, an SSL certificate. It'll cost you, I don't know, somewhere between $10 to $100 per year, based off of what they upsell you on. And basically this is a cryptographic certificate. And so what that means is that when somebody goes to your website, when they go to your server, basically their browser will be able to check if the server that they're going to is the server that you're supposed to be, right? So you have this certificate. Basically the certificate says, right, silicondojo.com is supposed to go to this particular IP address. So if you get spoofed, if you get sent to a different IP address, it should fail out because the certificate will fail out. Wait a minute, that's not the IP address we're supposed to go to. This isn't the right thing. Beyond that, it also, part of the SSL thing, is that it then encrypts the traffic. So it verifies a server that you're going to is the server that is documented in the certificate. Now notice the words that I say. I didn't say that it's the right server. I just said it's the one that's documented in the certificate. So if you change servers, somebody does something stupid, you can run into some issues. Anyways, so it says, okay, you're going to silicondojo.com. Silicondojo.com is supposed to be this IP address. You go there, it's the right IP address, yay. Then once it's figured out that it's the right server, they're allowed to do the communication. And again, as I say, the communication in between will be encrypted. Again, there's a whole class on setting up certificates. I like Cloudflare. Again, one of the things that I like with Cloudflare is they actually have SSL built into their DNS. Tony coming at 3:02. Tony's like strutting into the room. Yeah, I'm an hour late. Doesn't matter. Anyways, you can't fail. I'm sorry, Tony. I'm sorry, you came in too late. I guess can't allow you to pass this class. Good news is you don't get any grades in this class, so it doesn't matter. Anyways, Cloudflare has SSL built into it. One of the things I like about it is when it does the whole thing, basically you point it to your server, you set everything up within Cloudflare, and you don't have to set up anything else, which is nice. Again, you can buy a certificate from GoDaddy or whatever else. The other thing to take a look at, there's this site called Let's Encrypt, or I guess it's I don't know what the hell it is. It is a service called Let's Encrypt, a non-profit certificate authority providing TLS certificates to 450 million websites. So this is great. Instead of paying GoDaddy $70 a year for, I don't know, a bunch of bits and bytes, you can actually do Let's Encrypt. So you can install this onto your server. So you need a server, you install it onto the server, and this deals with the whole certificate authentication and that kind of thing. The nice thing about Let's Encrypt is one of the issues you get into in the real world of technology, especially cybersecurity, is something called rotation. So you'll hear about things like API key rotation, right? You get your API key from Twilio or whatever else. And here's the thing, the longer you own that API key, the more likely somebody is to get their sticky fingers on it somehow, right? So normally what you want is a rotation scheme. So every X amount of time, basically you get a new key, you plug the new key into your system, you retire the old key, you kill the old key so that it's no longer functional. Right? So you will hear about sometimes with cybersecurity incidents, basically where keys, some kind of key, made it out in the wild and all hell broke loose because they did not have a rotation scheme. One of the nice things is we use Let's Encrypt is they have a built-in rotation scheme. So if you go, when you get a certificate from GoDaddy, they give you the certificate. Now you can rotate it if you go through the whole process to rotate it, which you're not gonna do because it's long and tedious, right? The nice thing about Let's Encrypt is it's free and it has a nice little auto rotation mechanism. So they've got this whole thing built into it. They auto rotate the SSL certificates, and so it makes life a lot easier. We will have a class on Let's Encrypt because it's a great thing. But anyways, one of those things to consider. Okay, here. So let's talk about browsers for a second. So again, when we start talking about our web app, when we start talking about our architecture, one of the things you have to think about, again, all these different layers, all these layers. So the first layer that you're going to hit for your users is going to be that web browser, right? So they're going to be sitting in front of their computer, and they're going to open up Chrome or Firefox or Opera, and they're going to do it on whatever their operating system is. One of the big things to be thinking about from your standpoint is what browsers do you believe your users are going to be using, and then depending on how complicated your particular app is, will those browsers be compatible with whatever services that you're trying to do. Again, I've talked about that before. Again, going back to those HTML5 APIs, HTML5 APIs. Again, we can go to Mozilla. This gives us a nice list of the different APIs. And one of the things you'll notice if you click on these different APIs is if you go down, it will show you which browsers allow that particular API. So something called Battery Manager, Chrome at version 38. That's the other thing to be looking at here, is what version do you have? Again, if you're here in the United States, just shoot for the latest version. Everybody should be fine. Right? If you're in Zimbabwe, maybe people are running older versions. Again, depends on what your users are. Again, when we talk about this, we're thinking about requirements. What are the requirements of your users, not the requirements of my users? So Battery Manager works in Chrome at version 38, works at Edge at version 39, doesn't work on Firefox, works at Opera, not on Safari, on Chrome Android, not on Firefox Android, on Opera Android, not on Safari iOS, on Samsung Internet, on WebView, and not on WebView on iOS. So, if you're using these HTML5 APIs to do really cool things, right? If they're using Firefox on Android, and you want one of these things to work, right? You want one of these battery functionalities to work. It's simply not gonna work. So it's one of those things to consider. Again, like I say, with those web browsers and what you expect your users to do, and that's one of the questions you have to ask. Is at this point in time, do you request that your users use the browser of your choice, right? Our app doesn't work on this browser, so use a different browser. Or do you just find a different way to try to do what you're doing, or basically drop it? And again, that's the kind of thing you have to be thinking about, like with your project, and what are you actually trying to do? If you are trying to deploy a web app into the real world, it's going into the wild, right? You're putting a little hat on it, you're putting a coat on it, and you're shoving that damn thing out the door. Go live or die. I don't know, just don't come home, right? Right, there's going to be, a different expectation for how that thing is going to live in the wild. On the other hand, what if you're just kind of validating it, right? It's like, hey, we're creating this web app. We have a company, or we go to meetups or whatever else. Like, if I can go to a meetup and I can get 50 people, it's like I need 50 people to validate this idea. And so here's the thing. It's a piece of crap app. It's a crappy app, right? You go to your people and you say, look, it's a crappy app. We're just trying to validate the concept that it works. So can you try this app with Opera? Does anybody here have Opera? You all have Opera? Okay, can you try this app with Opera? And they go and they're like, fuck. And they leave. I'm like, what the fuck is Opera? Isn't Opera owned by Russians? God damn it. Why am I using a Russian Opera? Anyways, they go and they use it. They grumble because it's Opera. Who the hell uses Opera? But then they work through it and they're like, well, one, I hate using Opera. But two, this is in the wrong location and this takes a little bit too long. Right? You're going through the whole validation thing. And so again, that's one of the things to be thinking about with your web app is, are you doing validation or are you kicking it out in the wild? And again, there's going to be different expectations from your users and that kind of thing on it. Other things to be thinking about is basic security functionality with browsers is things like how they deal with JavaScript. So how much JavaScript do you put into your web application? Because many people have JavaScript blockers. One, they have actual JavaScript blockers. And then two, what's interesting, a lot of browsers now by default block JavaScript. And it's amazing how hard it is to get them to run the damn JavaScript, even when you want to run the JavaScript. You're like, no, but I need that pop-up. It's not a pop-up ad. It's a pop-up that actually does the thing that I needed to do. How do I get the pop-up to show up? So anyways, that's another thing to be thinking about with the browsers. The other thing to be thinking about too, again, depending on whether this is validation or whether you're kicking it into the wild, is that different apps will look different on different browsers. Again, so with HTML, you're using tags, you know, H1, HR, breaks, those kinds of things. How each browser shows those tags by default may look slightly different. Slightly different. It's again, it depends on what you're doing, but one of the things you want to do is you want to take a look at the different browsers you expect your users to use and then see how the hell it looks. Again, like with silicondojo.com. Look no farther from a disaster than your instructor. So we have silicondojo.com, right? And if you go on, I don't know, Mac, it looks good. Looks good enough. If you go on a smartphone, Silicon Dojo looks like absolute trash. The reason is I haven't had time to figure out what's going on with the mobile version of it, right? And so it's still H1 tags, it's still P tags, it's still all that, but when it shows up on the desktop, it looks fine, fine enough. When you pop it up on a mobile device, it's weird. It doesn't even make, I don't even know what's going on. So anyways, things to be thinking about there. Then CSS, when we start building your web app, one of the things to be thinking about is how much of the JavaScript that you used to use can you offload on CSS. So again, JavaScript back in the day, one of the reasons I still giggle at JavaScript behind its back is I was there. I remember what JavaScript was like when it was young, when it was a kid. Oh, just icky and dribbly and whatever. Anyways, if you go back to JavaScript back in 2005, big thing with JavaScript is like drop-down menus. Yay, I can make a drop-down menu. Remember like hover, like on hover or on over, whatever. That was a big thing. So if you go to a website, and then you have that kind of like dynamic functionality, if you want a drop-down list or a drop-down menu, or if you want to hover, or you want things to dynamically change, that used to all be done with JavaScript. Anyways, that's just how it was. One of the big issues, though, is we've had more and more JavaScript blockers. So what happens when you have these fancy animations in JavaScript, and then somebody has a JavaScript blocker, and everything just goes to hell. So the thing is JavaScript is a full-fledged language. It's something called Turing complete. Anyways, basically you can do a lot of stuff. You can hack people. Anyways, one of the things with CSS, which is nice, is it's not Turing complete. Or I guess it might be. I don't know. I was watching Fireship the other day, and he said it now is Turing complete. But anyways, you can't really hack anybody with CSS. Hopefully you can't hack anybody with CSS. So anyway, since this is considered more secure, what's been happening is a lot of that formatting functionality that we used to use JavaScript for, that's now getting moved in the CSS world. If you want a drop-down menu, you can do that in CSS now. If you want animations, you can do that in CSS now. You want on hover, you can do that in CSS now. So one of the things to be thinking about is when you're designing your app, is to be thinking about what language is most appropriate in order to do a particular task. Again, that whole idea, right? There's 20 ways to skin a cat in the technology world. Which way will you be skinning the cat today? And so for a lot of these things, it's much better to skin the cat with CSS. Oh, let's see here. We take a look at JavaScript. Basically, JavaScript is the client-side programming language. So there's lots of frameworks. I don't know what still exists and what doesn't. We'll get into more JavaScript classes in the future. Does jQuery still exist? There's jQuery and Ajax and all kinds of stuff. But anyways, basically the idea with JavaScript is it's Turing complete. It's a full-fledged programming language. But the nice part is that it runs on the person's computer. Right? So you got the person. They have their computer here. They communicate up to your server. And basically what happens is more or less a text file. A text file, it gets sent back to their computer. Just ASCII text, or UTF-8 really. But it's just text that gets sent back. And then within the browser itself, it takes a look at that text, and then it turns it into the program. The nice part about this is all that CPU, all that RAM utilization, occurs on the client computer. So again, one of the things you need to be thinking about is scaling, right? If you have a server up on the internet, and you expect 10 users a day, then whatever, do everything on the server. Do everything on the server. Resource utilization, who the hell cares? But what happens, once you start getting 10,000 users, probably still fine. What happens when you get 100,000 users? What happens when you get a million users? Right, you have 1 million visitors coming to your website every day, and if everything for your web app has to get processed on the server itself, that's just a tremendous amount of resource consumption. Again, that's one of the things we talk about at scale, right? If you do something for one user, the resource consumption is infinitesimal. Who cares? Who cares? Eli, it's using a kilobyte of RAM. Who cares? Again, for one user, fine. For 10 users, fine. 1,000 users, maybe still fine. 1 million users, right? If, instead of having your backend server do all the processing, essentially all it can do is send the text file to all these different users, now all of a sudden you have, wait for it, wait for it, it's almost like you have a distributed computer network. It's almost like we've had distributed computer networks for a long time before blockchain. But anyways, right? So the text gets sent, the text gets sent, the text gets sent, the text gets sent. CPU utilization, RAM utilization, all of that happens on these different things. And so you are distributing that resource utilization out to everybody else, which means it doesn't cost you a hell of a lot. Reduces load on your servers. I had a buddy of mine running a startup company, and basically he originally built all of his infrastructure, I think it was actually on PHP, and then literally 6 months later rewrote the entire core of his infrastructure on JavaScript. Because once they started seeing how resource consumption scaled, it started to get ugly really fast, and so what he realized was it was better to have the user's systems do the processing than it was to have his systems do the processing. One big thing to be thinking about with JavaScript, though, is that it is insecure for data because everything is sent basically as the text file, right? So basically all the information is sent to the end user, and then their browser parses it all out. But all this is basically a text file with a different extension, an extension of .js or something like that. So if you're sending things like social security numbers, right, again, that's one thing we see in the hacking world, is basically, a JavaScript file gets sent and it has people's names, and it has their date of birth, and it has their social security numbers, and then when the user does a search, it just finds the specific information the user wants, and then only displays that information. But the issue is all the other records were also sent with the JavaScript, and so literally if you have a text editor, you can open this up and see what other information is there. So it's insecure, so anything like social security numbers, date of births, any kind of thing like that, you want that on the backend server. You want the backend server to process and only send the specific data that the user needs for that type of thing. And again, with JavaScript, JavaScript may not work on some browsers because of JavaScript blocking either additional extensions or, again, web browsers are just web browsers nowadays. Then we got the backend languages. So again, for Silicon Dojo, our backend language is Python. I like Python and I cannot lie. I also like PHP. Okay, can I be honest with you? Can I be honest with you? PHP will always just have a little warm place in my heart. You can tell I'm an old school sysadmin and not a real coder because I say nice things about PHP. Real coders do not say nice things about PHP. But anyways, we got these backend languages, right? So you got the user, and they make the request up to the cloud, onto the server, and basically the backend language is here, again, PHP or Python or Ruby. And what's going to happen is that backend language is going to communicate with whatever it needs to communicate with in order to get the results that you want, right? It'll communicate, with, OpenAI to do an API call. It'll communicate with a SQL database in order to get information from a SQL database. It may do something with the OS. Basically, right, your backend programming language is going to communicate with whatever it needs to communicate with. It's going to bring all of that together, and then it's only going to send whatever it thinks that the user needs, right? Again, the good part about this is it is a hell of a lot more secure. It's a hell of a lot more reliable because you don't have to worry about JavaScript blockers and that type of thing. But just remember, every single request that a user is going to make, you're now going to have resource consumption on your infrastructure for those backend languages. One of the other things to be thinking about with backend languages, again, for what you're designing on, I remember again back in the days, you go back to 2013, 2014, you had Ruby on Rails and PHP, and they were competing. West Coast liked Ruby on Rails, East Coast liked PHP, sat down, talked with some real coders about what the difference was. One of the interesting things is, and again, this is what you have to think about, what you have to consider, again, being a real technology professional, is Ruby on Rails, in order to complicate things back in the day, was much easier. To get a programmer up to speed on Ruby on Rails was relatively easy to get them to actually be able to ship product. PHP at the time was harder. The issue is Ruby on Rails, how it processes. So you had Ruby, which is the programming language, and Rails, which is the framework. That's why it's called Ruby on Rails. The issue with that is, although it's easier to learn, it's harder on the resources. It consumes more resources to do whatever it was doing. And so that's why a lot of folks use PHP, because it was harder to learn, but it required fewer resources. Now again, this is the kind of thing that you have to be thinking about with what other language or framework that you're going to be using is what's most important. Again, what resource in your environment is most valuable? Is RAM the most valuable, or are employees the most valuable? Those are two resources. And then you figure it out. I don't know what the answer is. So that's one of the things to be thinking about backend languages. Then we have the frameworks, right? So basically frameworks, again, like Ruby on Rails, you have the Rails framework. Basically frameworks extend the functionality of your language to do whatever it is you want to do. All right, so we got our boxes here, and we have Python. So we use Python as our primary language here at Silicon Dojo. And then recently, we've been using Bottle, B-O-T-T-L-E, as our web app framework. So what the framework does is it allows you to write web applications, basically using Python, and turn it into a web application. There's also Django that are out there. There's Flask that's out there. There's Fast API. Again, we go back to that whole 20 ways to skin a cat. We currently are focusing on Bottle, and we will have classes on Django coming up. And so basically all these frameworks do is they extend the functionality of your programming language to do whatever it is that you're trying to do. One of the big things to be thinking about when you start using frameworks is, again, we go back to requirements. What are you trying to accomplish? I literally saw this. So you can go to Silicon Dojo. You can go to Silicon Dojo, and we have a forum. And there was a person asking about the difference between Django and Flask. And here's the thing, right? So Flask is a small framework. So Bottle is a micro framework. I think Flask is a small framework. So Flask has some stuff. Doesn't have a lot built into it. So if you want to create your own little REST APIs, you want to create some pretty simple things, you can do that with Flask. The thing was with Django, Django is everything and the kitchen sink and, you know, everything loaded in the garage too. Like Django just comes with everything, right? So if you want to build a membership site with a blog and all this kind of stuff, you can do it with Django relatively quickly. So one of the questions you have to ask yourself, frameworks, what are you trying to do? I know. Seriously, what are you trying to accomplish? If you're trying to create a relatively simple REST API that a few thousand users are going to hit a day, Flask is probably going to be fine for you. If you're trying to create the next Facebook, Django is probably the one that you're going to go for. Right? The different frameworks have different functionality that comes with them, and so you've got to figure out what framework works for you. You also have to be thinking about, again, just like with the programming languages, with frameworks, there's institutional knowledge. Your organization, the coders in your organization, what do they know? Right? If everything in your organization is already written on Django, right, it might be a bit of overkill, but you might want to create that REST API using Django because everybody knows how it works. right? You build something in Flask or Fast API, and nobody else in your institution knows how Fast API works. That can cause a problem for maintenance and those types of things. But things to consider there. Oh my God, page 2. I think I make these classes too long. I have to make cookies tonight. I'm going to Friendsgiving. After I meet the geeks, I'm going to Friendsgiving. So I literally have to bake cookies before 5 o'clock tonight. Will I be able to bake cookies before 5 o'clock? I'm not feeling good about it. Anyways, okay, so then we go to servers. So then we get to servers. All right, so we've talked about the browsers, we've talked about CSS, we've talked about JavaScript, we've talked about the backend languages. Now let's talk about the boxes. We talk about a box. Basically, we're just talking about what the hell this crap is running on. That's all we're talking about with a box. Might be a virtual server, might be a shared hosting platform, might be a physical server you have in the corner. What box is this running on? It's a GNU Linux box. Okay, never mind. Never mind. Can I find the senior engineer? So server boxes are basically what are going to be delivering the resources to the client, whether you run physical or virtual servers. Basically, what box are you going to be using? Hosting types for your boxes. First type is bare metal. Right, so let's say you want to create your application and you want to put it on your own server, right? Back when you were a kid, back in 2005, your daddy brought home a 1U Xeon server, and all your life you've wanted to build something on a 1U Xeon server. So you're going to do bare metal. Basically, the bare metal, all that means is you install everything physically onto the box. The operating system goes on the box. Python and your framework and your everything goes onto that box. Now, the good part about that is from a resource standpoint, you get the best performance from bare metal. So I use this way back in the day. Again, back when Everman IT was brand new, I had my own servers sitting in a co-location facility. And the thing is you just get the best performance, right? When your service is running, all it does is go through the operating system, it hits that Xeon server, and you're going to get the best performance they can possibly get. When you're thinking about bare metal, a bare metal server can basically be anywhere. You can have it in your house. Don't have it in your house, but theoretically you could have it in your house. You could have it in a co-location facility. Co-location facility is basically where you rent space in a data center. Your company may have its own data center, and there's also something called Metal as a Service. SoftLayer, I think, still has Metal as a Service. Again, not as big a deal as it used to be about 10 years ago, but it is something to think about. Again, you get the best performance because basically you just get the hardware with your operating system and you configure it. The issue with this, though, is if the CPU fan fails, everything crashes until you fix it. Again, I talk about that a lot because I've seen that. Again, I had the computer repair shop. You know how many times somebody wouldn't secure the little power thing for the CPU fan, and that little wire would just get really close to the fan, and that fan just zips around, and it just zips around for like a year or two, and slowly cuts through the power wire for the CPU fan, and then all of a sudden your server fails. What happened? CPU fan failed, overheated, everything died. So it's all fun and games until your system overheats and dies. So that's one thing to think about with a bare metal. You have shared hosting. So you'll hear a thing about this with, again, the things like GoDaddies of the world, where, again, if you're going to create an app, let's say with PHP or maybe with Ruby on Rails or something like that, it's basically called Platform as a Service. Basically, the idea with Platform as a Service is you just buy the platform. It has all the interpreters and everything else already built into it. You upload your code, and hopefully it runs. Hopefully it runs well, and away you go. You don't have to worry about CPU fans. You don't have to worry about the infrastructure or any of that kind of stuff. The issue you get to with shared hosting plans, though, is basically how many different services are running on that one server. So back in the day, again, you could do an ARP request on a GoDaddy server, and you would find literally like 300 or more websites running on one particular box. And again, you have all those websites running on one box. There's only so many resources. And so everything works pretty piss poor. So, something to think about with the shared hosting. VPS, so virtual private servers. This is like DigitalOcean. So we did a class a couple days ago using DigitalOcean or Linode. Basically what this is you get a virtual instance for a server. It has an internet addressable IP address, so it is on the internet. And then you can spin that virtual server up. You can do all the configurations, and you can have it do whatever it is that you want to do. And then you just pay for the resources that you're paying for. You can buy a $4 droplet or a $48 per month droplet, and it gives you different stuff, right? It'll give you different CPUs and different, speeds of storage and different bandwidth and all of that kind of thing. What I do have to say with virtual private servers, again, it is 2024, and these are actually pretty good options at this point in time. Again, you go back 10 years ago, it was an option. It worked. Not so good. Nowadays, they actually are really good options. So if you don't really need bare metal, $10-20 a month for a VPS might make a lot of sense. One of the issues you run into, though, with the VPSs is knowing what the hell you're buying. Because when you buy them, they'll be like, this VPS has 1 core, and this VPS has 2 cores, and this VPS has 4 cores. You're like, what does that mean? Why is 4 core better than 2 core? Because it's 4. Yeah, but but seriously, like what does that mean? That's one issue you get to with VPSs is it can be a little bit harder to fully understand what it is that you're buying. And again, when you do those virtual machines, when you rent those virtual machines, you're basically renting it at a resource level. So you're getting 2 cores. Even if you don't know what 2 cores means, that's what you're getting. And so it can be it's a bit like figuring out what works. Again, that's one of the things I talk about. Like when I use DigitalOcean, I use $6 VPSs. Because I find if you use a $6 VPS, especially for labs, it works great. If you buy a $4 a month VPS, it's hot trash. Why? I don't really know. I just spent $6. It's like when I was in Europe. I backpacked through Europe years ago. And what I found when I was in France, if I spent €2 on a bottle of wine, to my American taste buds, it was a pretty good bottle of wine. If I spent less than €2 on a bottle of wine, it was not a very good bottle of wine. What was I buying? I don't know. So I always spent more than $2 for my bottles of wine in France. And so it's like VPSs, spend at least $6. What's the difference? Who knows? Infrastructure as a service, IaaS. So when you think about building your platforms, again, IaaS is generally at this point AWS or Azure. And basically this is where you just go out and it's like a bonanza and you just buy stuff. You're like, I'm just going to buy stuff with the company credit card. It's going to be so good. Right, and so basically with infrastructure as a service, what's kind of cool, again, when you're creating your cloud application or your web applications, is you can just get compute. You rent compute. Was it EC2? I get so confused. There's so many. EC2? Is it EC2 or is it the S3s? I don't know. I think it's EC2. I think that's compute. Anyways, you go and you buy compute. And then you need storage. And so for that, you need some type of storage. They got like 30 versions of storage nowadays. And so you can say, I need this size storage at this performance level, and you buy storage. And then you need like routing, you need networking. So you go out and you buy the networking type service. And you need a database. So I think their database is Aurora. So you buy their database service. And basically we deal with infrastructure as a service. Is again, think about if the system is code. So in the old days, right, if you built a server, you grab the case, you put in the motherboard, you put in the RAM, you put in the CPU, you put in the cards, and that's how you build a server. Right? So in the modern world of AWS, logically, it's a lot like that. You just don't have to worry about, getting stitches from getting cut on the case. So basically you're like, okay, I need this compute. I need this storage. I need this database. I need this routing. I need blah, blah, blah. And essentially what you're doing is just combining all that stuff together to create, the platform that you're trying to create. This is the most scalable. It is probably going to give you the best performance. It can get stupidly expensive. It can get stupidly expensive. You ever wonder, you go to like AWS and you go to Azure, and they seem so darn generous. Who knew? Who knew Bezos was so generous, right? You're a little startup founder, and they give you all this stuff for free. So much for free, right? Free this and free that and free the other thing. And so then you build your platform with all this free stuff. And then you go from this level of utilization to this level of utilization, and you go from $0 a month to $10,000 a month. They didn't give it to you for free. They gave it to you to lock your ass in. It is a digital drug. Once you're locked in, once you're addicted to that AWS smack, you ain't ever gonna go back. And they know it. And so that's gonna be one of the things with IaaS. Again, functionally, is it bad? No, just how it is. That's how it is. You just gotta be careful when you're building your stuff out. Web servers. When we start talking about things like web servers, these are what are going to present your web application to the outside world, right? So basically when somebody comes, right, to your server, right, you got the Python down here, and then you have your bottle framework, and then for us, we have Gunicorn. We'll talk about Nginx in a minute, but right now we're talking about Gunicorn. So Gunicorn is the actual web server that presents your website to the outside world. Now, if you're just using HTML and PHP or Ruby on Rails, you may use Apache. Again, as a not boomer like me, I do love me an Apache web server. Again, if you're just setting up like an HTML website. Again, Nginx is what the cool kids currently use. If I know how to spell it. Nginx, right? Nginx is what the cool kids use nowadays. Again, if you're just setting up a basic web server, you can use Nginx too. And there's 50 different web servers out there. Basically, all this is when the traffic comes into the server, this is going to be the application that figures out what the hell to do with the traffic. Again, there's something called a vhost file, at least in Apache, and if you're looking for CNN.com or whatever particular website, it will route you into the appropriate folder. There's a whole bunch of caching mechanisms. Again, you get deep into this stuff, and you're going to spend a week learning all the functionality of these different web servers. But basically, that's what they do, is they actually present your application to the outside world. What you're going to be using really depends on what your requirements are and what the app needs. Again, in the Windows world, there's a web server called IIS, Internet Information Server. And so if you're building on the Microsoft stack, Active Directory and all that kind of stuff, you might use IIS. Why did you use IIS? Because you're on the Microsoft stack. It's really that simple. Really that simple. So that's basically what we're talking about with the web servers. Now, when you use like Gunicorn, one of the things to think about is there's different functionality. So again, for Python, there are different Python web servers. Gunicorn, Pyramid, I don't know, it's 15 of them. I don't know, there's quite a few. One of the things to be thinking about is basically what is their performance. So when you're using Python, Python actually has a built-in web server. So just with Python, without Bottle, without anything else, you can build a little web app with Python. You can, it's gonna suck, but you can do it. The thing is, basically with the built-in Python web server, it is single-threaded. So what a thread is essentially how many requests that the server can deal with at one time. So if it is single-threaded, it means that Python's built-in web server can only deal with one request at a time, which might not seem bad, right? It's a fast computer. Right? I've got a Xeon processor and 16 gigs of RAM and a solid-state drive. Even if it's only one request at a time, it's still really fast. Yeah, but what happens if it stops? Right, like it makes a request, and then the Twilio doesn't respond, or OpenAI doesn't respond, or the database doesn't respond properly, and then somebody else makes a request, somebody else makes a request. So these people's requests are not going to go through until it figures out what the hell to do with this request, and that's when everything goes to hell. Why we use Gunicorn as the Python web server is called multi-threaded. So basically it can deal with multiple requests at the exact same time. So if one request goes out and just bogs down for some stupid ass reason, it can still continue to process other requests and get those requests accomplished. And so again, that's the kind of thing you need to be thinking about with the web server that you're going to be using. There's also weird functionality too. Again, if you're building other apps, you're not dealing with Python. Oh, what's it called? Light HTTPD? Is that correct? Does that still exist? Anyways, back in the day when I was first building Everyman IT, Light HTTPD was a web server, and its claim to fame was what's the word for it? Not passive web streaming, pseudo web streaming. Words. So many words. Something called pseudo web streaming. Okay, so if you wanted to deliver videos like a YouTube, again back in 2009, you had something called progressive download. And this is where basically a file downloaded to your computer, and then you could watch the file as it downloaded. Then you had actual streaming, real streaming. So if you had what's called a flash media server, that was a server that we had. Basically, you would be watching the video, and then wherever you requested to hop in the video, it would simply make the request to start there. So that's what streaming was. So this would download the entire damn file. This would only send traffic for what you were actually watching. Then you have this thing called pseudo streaming, which is kind of the middle, where basically you watch the video, it starts downloading the file, but as it downloads, you can also skip through the video file. So it's literally a poor man's streaming. So you still get the bandwidth consumption of progressive, but you do get the usability of streaming. So it wasn't too bad. Anyways, the important thing was, in that particular world, Light HTTPD was the web server of choice. And so again, that's what I'm trying to explain to you folks. Eli, what should I use? What are you trying to do? Are you trying to do progressive video streaming or pseudo video streaming? No? Okay, then probably don't use Light HTTPD. Right? That's the kind of stuff to think about. Again, it's all products. It's all products. Then we deal with reverse proxy servers. So we've been dealing with reverse proxy servers a lot, or at least one of them, Nginx, for our projects, because when you deploy Gunicorn, you're supposed to deploy Nginx. Eli, why don't we use Apache with Nginx? Because they don't tell you to do that. I just do what people tell me to do. Like everybody's like, oh, I want to be a computer geek so I can be a rebel. Like, okay, that's also not our field. You want respect, and you want a stable job, and you don't always feel smart, and you want to be a rebel. You know, that sounds like a great job. That's not what we do, though. That's not what we do. We follow a lot of instructions. So anyways, basically you get these things called reverse proxy servers. The main idea of the reverse proxy server, again, you have something like Nginx, you use a reverse proxy server. So basically, generally behind a reverse proxy server, what happens is you have multiple servers that are providing essentially the exact same resource. So let's say you have your little website, right? And basically for redundancy purposes, for load balancing purposes, that type of thing, you want that website to be delivered from multiple different servers, right? So if one server fails, but a user comes in, they'll still be able to get your website. If a whole crap ton of users come in, they'll get load balanced over these different servers. So hopefully they keep access to your thing. Anyways, that is what a reverse proxy server is using something like Nginx. And so if you take a look at this from an architectural standpoint, basically what happens is you get your little cloud over here, it comes in, you have your Nginx, so this is your Nginx box, right? That basically goes into a switch, that then goes out to however many servers you have set up. And again, there might be geographic routing here. There might be like, again, you get really coding. Again, whatever you build, whatever you want to build, you can build. And so again, these are your web servers, web servers. Well, again, they may have a database, right? So you may have a database cluster in the back, so some kind of SQL database cluster. So with a cluster, basically the idea is all these systems are communicating with each other, doing something called a replication strategy. Again, the idea being, if any one server in the cluster fails, you still keep the resources. So basically what happens is these web servers that are presenting the website, presenting the web application to the users out here, you have them, they're going back to talk to the SQL server that's in your cluster. And so the idea is if one of these servers fail, traffic continues through. Again, you got a cluster of your SQL servers, so if one of those servers fail, they keep their communication up. And so that's kind of the idea of a reverse proxy server. On top of that, reverse proxy servers can have caching mechanisms inside. So the idea is if traffic is coming through and basically one user asks for the exact same piece of data the last user asked for, instead of going all the way through this whole process, it'll have its own little cache and it will return from its cache instead of dumping resource or using resources on this type of thing. Is everybody really keeping up? I see no questions. I see no questions. I'm not sure I trust you people. I need a koosh ball. I need a koosh ball. I need a virtual koosh ball. One of these days. You think it's a joke. You think it's a joke. All of a sudden a koosh ball is going to come out of the screen and like smack you in the face. Like, Like, yes, I am Neo. I can send a koosh ball through the camera. Okay, no questions. Let's see here. Reverse proxy servers. Okay, we gotta get through this. I got cookies. Fuck. I really do have cookies. I really have cookies to make. Okay, then we talk about databases. So in this mess, we're talking about databases. And so basically what databases store are records. Think about it as the Rolodex for the technology world. Basically, when you think about it, again, let's say you have a table for a relational database. You essentially have columns, and basically you have an ID, you have a name, you have, I don't know, gender, and you have age. Scale this out, and this is basically what a database is, right? Each one of these columns, you know, they have something called a data type generally. So a name would be a string or character, gender would probably be a string, age would be an int, ID would be an int. You can do blobs. So a blob, don't do a blob. You can actually store files directly into a database. Don't do it. No, it is possible. No. Anyways, this is all a database is. Again, for what you're going to be building, for your infrastructure, you have to think about what kind of database you want. So there are things called relational databases, and so this is sort of what a relational database looks like, is you have something called a schema. The schema is basically how the data is formatted. You have tables, you define columns in those tables, you define the data types for those columns, and then you start using the damn thing. The nice thing about relational databases is they are, whether they're acid, atomic, consistent, other things. I need more notes. Yeah, there's all these words. Anyway, basically the thing with relational databases is that they are more or less stable. You put information into them, and basically the information is going to stay there, right? You do your transaction, the transaction goes in, and you don't have to worry about it anymore. The issue is with relational databases is they don't necessarily scale the best. One thing is you create these schemas, you actually have to design these schemas, and then if somebody wants to change things, you have to do this alter table, and then everything goes to hell. Everything was sunshine and cotton candy until we altered the table, and then it went to hell. Anyway, so you got these schemas, so you have to deal with that. Actually scaling out the relational databases doesn't necessarily work that well. Again, we talk about at scale, and so that's one of the things you have to work with. Relational databases, very reliable, generally very reliable, very good, doesn't scale very easily, can't be modified very easily. So that's where we have NoSQL databases. NoSQL, the database that actually changed the world, Not blockchain. Not blockchain. Blockchain is a poser. Blockchain is a poser. Blockchain bought that really fancy Aston Martin using their mommy and daddy's credit card. NoSQL bought that Toyota from their own hard work. Anyways, that's my own pet peeve. We'll talk about it later. So NoSQL databases basically are schemaless. They're called schemaless databases. You don't have to create this whole mess. You don't have to create this whole mess. Oh, just like coders like it. You write your code, you dump the information into the database, and you walk away. The nice part about this is you don't really have to modify anything. There's no schema to modify, so you don't have to worry about that. You don't have to think about what you're doing before you do it. Why would coders think about what they wanted to design before they started building it? That would be stupid. Anyways, so you don't have to think about it. You can modify things basically as you go. It is incredibly scalable. Again, most of the social media sites, at least back in the day, one of the things that made them take off, again, why NoSQL literally changed the world, is they were able to use these NoSQL databases. They just scale to infinity and beyond. Absolutely great. The issue with NoSQL databases, though, is, sometimes they lose data. Sometimes data go by. And so one of the things you have to think about with a database is if you're doing an inventory control system, if you're doing an accounting system, you want a relational database because you don't want data to go bye-bye. Right? Might be a little bit slower, might be harder to scale, might actually have to think about what the hell you're designing before you build it. But once you built it, pretty damn solid. NoSQL, on the other hand, if you're trying to create a social media site, or maybe like some kind of logging mechanism site. Let's say you have like thousands and thousands of IoT devices, and they are just fucking throwing data at your servers. Right, if you lose a couple of incoming, communications from a couple of IoT devices, does it really matter? I mean, you're looking for trend lines. If you lose a temperature value for a 1 minute time period, does it really matter? That's one of the things that can be valuable for NoSQL. Is again just insanely scalable. You keep swiping that credit card, and that database will just get as big as you want it to be. So things to be thinking about. Things to consider, again, with different database types or database servers. Again, so you hear about the database, you hear about relational databases or NoSQL databases. Then there's the actual database servers themselves. So you hear of Postgres. So Postgres apparently is what all the cool kids use. That's why I use MySQL. Anyways, Postgres is what the cool kids use. MySQL is the one that I like. One of the things to be thinking about with whatever you're building is, again, these transactions that we're talking about. So MySQL is apparently, I've been informed, is faster on inserts. So let's say you need a relational database, and you're just throwing data in it, and it's got to grab that data, it's got to put it in, and it's got to grab the next data. MySQL is apparently faster with inserts. Postgres is faster with selects. So selects is where you read from the database. So again, one of the things to be thinking about with your architecture, what is most important to you? Is an insert most important to you? Or is a select most important to you? And then pick your server. As a rebel do. As a rebel do. Yep. Check, 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 check. Modern revolutionaries. Anyways, again, you get things like SQLite. I love SQLite. We teach SQLite a lot, but it has absolutely no security. You can literally copy and paste a SQLite database. You can open a SQLite database in a notepad and take a look at what's going on. Again, what are you up to? There's new functions to be thinking about with things like NoSQL and vector databases. So vector databases are part of the whole AI thing. It's not AI, but kind of sort of AI. Really cool. We're going to have classes on it coming up. But some things to think about is different database servers, again, MySQL or Postgres, actually allow you to do things that they may have not done before. One of the reasons people like Postgres is now it's no longer just a relational database. You can also do NoSQL in Postgres server, and you can do vector databases in Postgres server. So again, that's one of the kinds of things to be thinking about with whatever you're building your architecture on. You have hosted databases. This is something that you might really want to look into, especially if you're a noob, and especially if you don't have a lot of money for maintenance or whatever. So DigitalOcean offers this. I'm probably going to start using it for some projects going into the future. But basically $15 a month, and they just give you a database service. Again, we talk about service-oriented architecture. I don't want to worry about the operating system. I don't want to worry about the CPU fan. I don't worry about that crap. I just need tables. What do I need? Tables. You mean for $15 a month, all I get is tables? I want that. And so that's basically what you get with hosted databases now. And again, this might be something for you to really look at. Again, at least if you're going through the validation, you can get everything up and running. It will be as secure as you design it. You shouldn't run into any kind of weird quirks. And again, it's relatively inexpensive. Again, $15 a month for a lot of those to start with. We have storage. So we start talking about storage. So this is records. This is right. We talk about data, like what kind of data? So databases deal with records data. Storage deals with actual files, right? So video files, image files, files, right? That's what we're talking about with storage. So one of the things to be thinking about is where is your storage going to be? So again, when we design using either Bottle or Django, one of the things you'll notice with these frameworks is they have a static function. And so basically the static function is where are the static files residing? And so when you design for Bottle or Django, the static files should be somewhere else. And so the idea is any functionality a server has is also a vulnerability. If you can upload files to a server, not only can you upload files to a server, but a hacker might be able to upload files to a server to be able to manipulate your system. Right? So one of the things with cybersecurity is you try to silo everything as much as possible. So even if one system gets compromised, they can't screw up everything else. So one of the things with static files, the idea here is you have your Bottle or Django app running on this particular server, and then all the static files are sitting up on AWS, or at least on another server somewhere else, and you're pointing to that particular server. So that's the idea. Now the static files, again, when we do our projects, the static files can be on this server, but the idea is it should be separatable. You're going to hear about things like SSD versus platters. Basically, want to take a think about this, again, especially if you're building your own server, or you're getting things like VPSs or whatever else. Again, two different types. So solid state is NAND storage. I don't know, it's like storage using transistors. Platters are basically like highly technical records, essentially. So basically with the platter drive, the platter spins. There's a head that reads or writes on the platter. The good thing about platter drives is that they are relatively inexpensive. You can afford a 20 terabyte platter drive right now. Relatively inexpensive. The other thing with platter drives, people don't think about platter drives, is that they fail, but they don't get consumed. That sounds weird, right? Here's the thing. When platter drives die, they die. It's like, blah. One minute the platter drive's fine, the next minute the platter drive's dead. How long will the platter drive survive? Will it be 5 years? Will it be 10 years? Will it be 30 years? Who the hell knows? That platter drive is going to keep being a platter drive until it decides to die. That may sound like a weird benefit, but it actually is a benefit depending on what you're doing. So solid state drives are going to be much faster, incredibly fast compared to a platter drive. But the issue with that is it's going to cost a lot more per storage unit, per terabyte. So they're generally, I don't know what it is today, but something like 4x, right, the cost. So again, it depends on what you're doing. If you're just doing a little website, then just get the fastest drive you can and shove it in there and you're fine. Again, if you're storing video files, see, if some jackass uploads 40 gig video files onto your service for you to transcode, maybe you won't put that on the platter drives. Again, your resources. The other thing to be thinking about solid state drives, you don't have to worry about this on VPSs. If you go to DigitalOcean, you don't have to worry about this. But if you're running it, if it's bare metal, solid state drives are actually consumable. They have a certain number of what are called IOPS. And basically what happens is every time that little transistor flips back and forth, it's weakening. And at some point it fails. And basically they give you enough headroom, so more and more of those fail. But you're literally actually consuming your solid state drive. And so if all you're doing is like reads from a solid state drive, it'll probably last for a long time because you're just reading. You're not writing to it. But again, with those databases, especially something like with a NoSQL database that you're hammering the hell out of, that solid state drive may fail in a shockingly fast amount of time. So that's something to consider. Also, too, when you're building your infrastructure, again, there's consumer grade solid state drives and enterprise grade solid state drives. Why is an enterprise grade 2 or 3 times more? Again, it actually goes back to how long it will last, right? This 1 terabyte consumer one costs $50. This 1 terabyte enterprise one costs $400. Why am I going to spend $400? Well, how long do you think your company's going to last for? I mean, if you actually believe your company is going to last longer than a carton of eggs, you might want to spend $400 for that enterprise class solid state drive. One of those things to consider. RAID, no. No. I don't care. You're some little noob, some little 18-year-old walks into your server room and says, "What about RAID?" I just want to take your hand. Again, make sure it's open. Don't fist. That's abuse. Fist is abuse. Keep the hand open. Smack them. RAID sucks. RAID is so horrible. RAID. Oh, RAID. RAID is god awful. So basically what RAID does is it ties multiple physical drives into one logical drive. There's RAID 0, there's RAID 1, there's RAID 5, there's RAID 10. They all suck. They're all horrible. Don't use RAID. It's 2024. There's better things. We can go into it, but I need to bake some cookies in a couple of minutes. Just say no to RAID. You will hear of storage arrays. And so again, we start talking about these clusters of clusters of clusters of clusters of clusters of clusters of clusters. All right, so you got your little Nginx. That points to all these boxes. They then point back, to databases or whatever. And then there's let's say there's files, right? You got video files or whatever else. Basically, there's 2 types of storage arrays that you'll be using generally. There's something called a NAS. NAS is a network attached storage device. And basically what this is a storage server. You plug in hard drives, it auto-magically turns those hard drives and whatever volumes you need. It gives you network access to those volumes, and that is where basically your data is stored, right? The good part about this is, again, if one drive fails, it should fail over to the other drives. It does all the fancy stuff for you. The issue with a NAS is that it is a single point of failure. If the NAS fails, everything fails for you. You might have something called high availability, where you can have multiple NASs that are connected together. They do a replication strategy. They replicate data between each other. They then have a heartbeat connection. Bop, 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 bop. If one of them no longer senses the heartbeat, they spin up, they become active, everybody starts using them, and away you go. This is a good form of resiliency. Not a great form of resiliency, but it does work. So that's why there's something called SANs, storage area networks, which are basically kind of sort of clusters of those. So you create a cluster, a storage cluster. Each one of these boxes in the storage cluster has however many drives in there. They do their whole little replication strategy. You communicate with the storage cluster, not necessarily one specific box in the storage cluster. If one box fails, the other ones keep everything going, and away you go. This gets expensive. Just to be clear, this, very expensive. NAS, not so much. That, yes. But again, depends on what you're doing. When you hear about storage, when you go out, especially to DigitalOcean or Linode, and you're going to be buying storage, there is block storage and there is object storage. Block storage basically acts like a volume in a hard drive. If you're going to install things into it, that type of thing, you may want block storage. Basically, you get a volume. You get a D drive, an E drive, whatever else. You mount it like a drive. It looks like a drive. You treat it like a drive, even if it's all cloud-based. And there's also object storage. Basically with object storage, it's more like you just throw it. You're just throwing stuff into a bag. You kind of like write your name on it. You're like, mine, and throw it in the bag. Mine, you throw it in the bag. Mine, you throw it in the bag. Just kind of all just goes into this pool and things are identified by who the owner is. And so it's good for like just basic files or whatever. Not the greatest performance out there. You can't interact with it like you would a volume on your box, but might be a way to shove images or whatever. One of those things to think about. Then we have thank God. 404. Okay, got to get through this. Got to make some cookies. Eli's got to make some cookies. Then we have caching mechanisms. So this is something for you to think about. Again, we talk about storage. We talk about, platter storage, and we talk about flash storage, and we talk about tape storage, right? The most reliable form of storage is still tapes. And so if you really want something to like get your mind around in the real architecture world, have you ever heard of FLAPE? Have you ever heard of FLAPE storage? This is real. FLAPE storage is real. So basically, with tape storage, like real tape storage with robotic arms, it's really kind of cool. Like you can go to IBM, and they have these cabinets. And in the cabinet, you get all these tapes. Each tape can store like a terabyte of information. So like each one of these cabinets can store like 100 terabytes of data or something ridiculous. But then in order to add more, you just literally put another little cabinet on, and then the robot arm can go down. You can have like 10 of these cabinets. So basically you have a storage medium where you don't have bit rot, the data doesn't die, you have an absolutely massive amount of storage, but it's slow. It's so slow. It's a tape. Literally, the robot arm has to find the tape, literally puts it into the player, literally finds the position of the data, and then pulls it out. So what FLAPE is a caching mechanism where when you pull the data from the tape, it will then store it into a flash drive. It's basically a solid-state drive array, so that then it is now cached in the solid-state drive. So if somebody else asks for the same information again, it will simply come from the flash drives or from the solid-state drives instead of going through that whole tape process. Again, architecture in the real world. Moken writes down. I saw you, Moken. Give me a second. What's up? All right, I did say ask to unmute. What's up?
What's up, you hear me?
Yep.
I don't understand what is the difference between the storage service and the database service. Is it the database service just for making queries, or a database service includes storage or not?
So the database service is basically records. So, your ID, your name, your age, inventory control, like that type of data. Like, so I do a search and I want to find, or I want to do a blog post, and I want the text to be stored somewhere. That would be stored in a database. An image, so the actual picture or a video file, files are storage. So records, there we go. Records are databases, files are storage. Does that make sense?
Yeah. Thank you.
Cool. Yep. That's fine to ask those kind of questions. Those are real questions. If you don't, people don't ask that kind of question, then you get confused. That's all downhill from there. But anyways, don't worry. You won't fail. You won't fail because you also won't pass, because we don't have grades. So basically, again, the caching mechanism is just a way to cache data as it goes through. As we talked about before, Nginx can act as a caching mechanism for your web servers. So information that's being requested multiple times, instead of going all the way back to your web servers, it can just be gone through from the Nginx. You can have accelerators, so like with a NAS system, so like with those NASs or those SANs, right? They have drives in them. Generally, those drives are platter-based drives. Again, slower, but more reliable and better cost for performance. But one of the things that they'll do a lot of times is put a solid-state drive in there. Basically, they'll call that an accelerator. So the idea is when somebody requests data, it will get stored in a cache on that solid-state drive. So when the next person makes a request, it'll get pulled from the solid-state drive instead of having to go to these much slower platter drives. So that's the idea of kind of what we're talking about with caching. One of the interesting things that's come up nowadays, and again, the modern world, old becomes new again when you think about caching, is something called static site generators. So what a static site generator is so with a content management system, WordPress, Drupal, those kinds of things, a user goes to that site. When they go to the site, the database, there's a request made to the database pulls a whole bunch of information and then dynamically writes the web page that you're looking at. Right? You go to the website, it goes, okay, you're going to home, this is the featured image for home, this is the text for home, this is the additional stuff for home, here's home, and it dynamically writes that for you. Well, here's the thing, that takes time. Again, we talk about latency. That takes time. To go to the database, to pull the information out, to dynamically write that page, takes an amount of time. So what static site generators are kind of interesting. What they do is just when you modify your CMS, your content management system, they go through and they'll automatically write static pages for you. So you change things in the CMS, it goes through and it'll do, at one time, it'll go through and it'll rewrite all the pages that need to be rewritten as static pages. And then when somebody comes to your site, instead of your site having to go back to a database and do that whole communication scheme, it now just delivers the HTML, CSS, and JavaScript just like it's a static site. So that's kind of like one of the caching mechanisms you can do. Content delivery networks, CDNs. Again, this kind of goes back to that whole GeoDNS thing, and in the modern world doesn't matter, but also in the modern world it's a lot easier to pay for. So basically the idea, let's say you got the United States, and you have your server. You have your server here. And let's say somebody accesses information from your server. So they have to make a request here, and it comes back. And all of that has to come back. The images have to come back, the video files have to come back, the whole 9 yards. So what a CDN is, a content delivery network, is if you go to Cloudflare, if you do Amazon, they have data centers all over the country and all over the world. So basically what happens is when the user makes a request, the data will actually initially go to the local server, the server that's closest to this person, and then send the data to that person. Right? The reason being is because if somebody else within that area makes the same request for a file, it will now get pulled, again, from the closest server instead of having to get pulled all the way from the main server. So again, this is important for things like large files, updates, that kind of thing. It's a way to try to take the load. It takes a load off your main server. You start distributing the load. And then also, again, for that whole latency thing, supposedly it makes it faster. It can be good. It can be good. It can also be expensive and can be buggy as hell. CDNs can be so buggy. Anyways, it can be expensive. Basically, how you pay for it. So again, back when I had Everyman IT, I used a service that used a CDN for a while. That did not go swimmingly because they didn't understand how their architecture worked. So basically, the files were stored back in the main storage, and then basically data went to the servers in the CDN. But the funny part, the interesting part is that Amazon, AWS, charged for this, but did not charge for this. So the last mile from the CDN server to the user, there was no charge. This cost $0. But this was full charge at 9 cents per gig. The issue was, at that time, it didn't have millions of viewers. So I had thousands of viewers. And the issue is you people were all over the damn world. So the problem was, whenever you made a request, that data was going to the CDN, but nobody was actually using the same server as anybody else. So all of these communications were getting charged. And supposedly, where I was supposed to save the money down here, there weren't enough physically close enough users to actually save money that way. So again, with everything you do in technology, make sure you understand how you're going to get billed and how that's going to be affected by your users. And then we have Cloudflare for DDoS protection, denial of service or distributive denial of service protection. So Cloudflare is interesting. Again, can be good, can be bad. I like Cloudflare for DNS. Cloudflare for DNS. Awesome. Cloudflare for other services. Quirky. Quirky is a word. Quirky is a word. So basically, for the denial of service, how they prevent these types of attacks. So denial of service attacks is, again, those ass in seats, right? I'm going to consume seats that I'm not actually going to sit in. And so then there's no seats for the people that actually want to sit in the seats. Right? That's a denial of service attack. So anyways, the idea is you have your server here, and it just gets hammered by all these hackers, and then it goes down. Right? There's ways to prevent this, there's ways to mitigate it, but it's very, very, very expensive. So that's where Cloudflare comes in. That's where Cloudflare comes in. So what you do in your DNS is you set the IP address settings to Cloudflare. 186.25.2.2. I don't know, whatever else, right? So CNN.com goes to Cloudflare. Cloudflare then has a record for your actual IP address. 205.66.44.1, right? Your box sitting over here. So basically what happens is traffic goes into Cloudflare, and then basically, as long as Cloudflare sees that it's good, it will then redirect and route it to your actual server. So they got a lot of fancy stuff. They got a lot of expensive stuff. If somebody tries to do a denial of service attack against you, they will hit Cloudflare's infrastructure, and Cloudflare should mitigate the attack and only allow legitimate traffic to get to your server, or at least mitigate it to the point that your server doesn't go offline. That's basically the idea of Cloudflare. And any kind of that kind of thing. Arbor networks, kind of thing. It can be expensive. It can be very expensive, depending on what service you buy, and also can be, wait for it, quirky. Very quirky. Again, that's one of the things I have to think about with security, right? Like if you put a lock on the door, here's the thing, right? Everybody's like, well, you need a lock on the door. Well, yeah, but then your employees can lock themselves out. Like, what's the risk of your employees locking themselves out, right? Again, it depends on what you're doing. Again, I think about that, like how lucky I am, how privileged I am to not be of my grandfather's generation. I actually went and saw the factory my grandfather used to work in. He spent like 20 years of his life working in this factory. Again, my grandfather was Depression era, right? And do you want to know why? Do you want to know why I was able to see the factory my grandfather worked in? There were no doors. There were no locks. He was just there. Eli, let's go see my old factory. And you just walked in. And it was an old factory, right? Well, that's the thing. If you don't have locks, in the doors, you can't lock anybody out, one way or the other. And so that's one of the things to consider, right? So you get DDoS protection. What happens if a legitimate user is trying to do something that looks like a DDoS attack, and then Cloudflare shuts them off? Or what if Cloudflare is just quirky that day? As Cloudflare can be. So anyways, there we go. That is a basic class. 2-hour and 17-minute class on web app architecture. I feel a little alone today. Where's Jock? Where's the back and forth with Jock? Anyways, guess he didn't want it. Any questions? Any questions? Question. Mohin, yep.
When we talk about backend languages, and we talk about JavaScript that doesn't consume much of the resources, is the backend languages like Node.js and Next.js would seem like JavaScript? Doesn't those two languages don't consume a lot of resources in the server?
No. So I didn't say Node. I don't like Node. I'm an anti-Node person. No, so he's talking about Node. So Node.js. Again, we talk about frameworks. So Node.js is a framework to make JavaScript work on the back end. So basically the value of Node.js is you can take all the syntax and all the way that you know to code in JavaScript, and with that you can start coding on the actual server. But that is going to be running on that backend server. So Node.js in this regards is just like Python or PHP or Ruby. that is running on your server. You just happen to be able to write code in the same syntax you know if you already know JavaScript.
Yeah. Another question about the web server. Is the web server is box itself? Is it specifically for web servers or just the software like Apache that in the box that give it the functionality of a web server? And
Yeah.
is it Apache hardware or just a piece of software that can run it on every box?
Yeah, so Apache is just software. So Apache, Nginx, Lite HTTPD, whatever, that's just software. And so you install it onto the operating system. So again, if it's a physical server, then you put it on the physical server. It's a virtual server, you put it on the virtual server. So that is just a piece of software that is installed onto the operating system.
Yeah, thank you.
Yeah.
Thank you.
Cool. Okay. Oh, anybody else? I gotta go bake some cookies. I'm gonna make some fast cookie baking. Wife's gonna be like, what are you doing? Baking cookies! Baking cookies! Okay. Oh, serious, I gotta go bake some cookies. So any questions? Any questions? Thanks for the class. Cool. Is SQLite have databases for it or just file in our computers? That was Moken. Already. Well, anyways, so you asked a question. I read it. So SQLite. Is SQLite have databases for it or just a file in your computer? So, that's the thing. A database is a file. That's why SQLite is dangerous. So you have SQLite. You have SQLite, right? And you connect to it. So we use Python to connect to it. Here's the thing. It is a file. It's a dot, whatever you call it. Let's say it's a .SQL file, right? So basically, with Python, you're communicating with it this way. You make a select statement or you make an insert statement, and then it gives you the response, and that's what you're doing. But the other thing to understand about this SQL file is it's just in your file structure, right? So somewhere in your computer is a .SQL file that is this database. And that's why SQL is dangerous, because there's no permission scheme, there's no built-in permission scheme, there's no built-in encryption scheme. It's basically it's a fancy text file. You can literally copy a SQLite database file, move it to an entirely different computer, and open it in Notepad. You can literally open it in Notepad and see what the hell's in there. So with a database, the database stores values as records, and the database itself is a file, if you're doing it this way. So there we go. I'm not going to look anymore. Because I got to make cookies. So, okay, so we got a class on Friday on sanitization and filtering and that kind of stuff. There's another class here in Asheville on Tuesday. And I got to go do cookies. I got to make cookies. See y'all later. So many cookies. Cookies.